This is the Smart Buildings Academy podcast with Ethan Morris, episode 519. Hey everyone, welcome to the Smart Buildings Academy podcast. In today's episode, we'll be learning how to correctly perform a point-to-point checkout. All the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/519. Again, that's podcast.smartbuildingsacademy.com/519. The objectives for today's episode are to understand the purpose and importance of a point-to-point checkout. And then we'll identify the required tools, documentation, and the preparation steps that you should be taking before we start these point-to-point checkout. Thirdly, we will learn the correct process for performing a point-to-point checkout. Then we will recognize quite a few of these common errors that we can see when we do these point-to-point checkouts, and then we'll learn how we can prevent them so they don't happen to you. And then lastly is we will develop habits for accurate documentation so that we'll make sure we got our logs correct. We're writing all this stuff down. So we're going to develop the habits for documentation and reporting through this episode as well. So let's jump in. So to start off here today, let's talk about what a point-to-point checkout is. Simply put, a point-to-point checkout is just the verification of each field point from device to controller to workstation. We're basically just verifying that all of our hardware points are working. So this could be temperature sensors, relays, actuators. It could even be programming logic. If we've already set it up, we're going to check. We're going to test all this stuff, make sure that it's working correctly. The big idea here with this is to remember there's a difference between point-to-point checkout and the installation side. So when we get to the point-to-point checkout, we are already past the installation side of things. So we've already installed our sensors, we've installed our software, we've installed the any output devices that we might have. All of this has already been done. So we're past the installation part. We're now into the checkout part. We're checking these devices that we've already installed for operation. So again, we start off by verifying all these things. The next thing that it does for us is it confirms our wiring integrity. As you know, we have to wire every one of these devices up, so we need to make sure that they're wired correctly, and that's part of this point-to-point checkout process, is to confirm that our wiring is correct and that we're reading good values from our inputs and that we are able to command the outputs through that good wiring. The next thing here is ensuring that we have the correct I/O configuration on our software and on our controllers. So this is confirming that points are landed where they're supposed to be, that devices are wired up to where they're supposed to be. So we have to verify all these things, and that's what the whole idea with a point-to-point checkout is. And then the last thing for this second point here is we also check any programming logic that we've already built out as well. So that confirms our wiring integrity, our I/O configs, and our programming logic. And then we go down to this third point. Point-to-point checkout also ensures that every sensor and actuator respond as they're expected. So this makes sure that everything's operating how it's supposed to. We have good values from our inputs, and our output commands are operating as they should. And then just one little note here at the end. This is the final note here for this slide on a point-to-point checkout is that point-to-point checkouts are the final quality assurance step before we get to system commissioning. So making sure that we do the point-to-point checkout correctly and very thoroughly can really help us when we get to the commissioning process. So we really got to make sure that we got this lined out correctly and we have all these steps worked out so that it's going to be a little bit easier on us when we get to commissioning. So that is what a point-to-point checkout is. So next, let's talk about why a point-to-point checkout matters. It matters because it ensures that we have reliable system performance. Again, we're verifying all of our devices. We're verifying that our software is working. We're verifying that the programming logic's working as well. So with all those things verified, then we feel pretty good that our system's gonna be pretty reliable. Everything's performing how it's supposed to. Excuse me. The next thing here, this one's a huge one. It matters. Point-to-point checkouts matter because it helps prevent costly rework during commissioning. And I've gotten parentheses here. I think we all know this one. Time equals money, guys. Okay, so if we're having to go back in the commissioning process and do rework from things we missed when we should have caught it during the point-to-point checkout, we're just wasting time and money here. It's very important that we make sure we have the point-to-point checkout done correctly and we've verified everything. Don't skip anything. And when we do that, that will prevent this costly rework that this is talking about here. The flip side of that, though, is that it matters because it can also build confidence with your customers or the clients and even the building operators, or even if you have new guys on your team. Point-to-point checkouts are a good way for them to get familiar with these devices, how things are wired, and how to test and troubleshoot some of these things as well. So always good. Confidence is always a good thing to have for yourself or your team. And if you can apply some of that confidence onto your building operators and owners, even better. So again, point-to-point checkouts matter because it helps us build confidence. And then lastly on this slide here, it supports long-term maintainability and troubleshooting. And again, this ties in with what I was saying there a second ago. Like if you have new guys on your team and, if you find a bad sensor somewhere, take them out, show them while you're doing this point-to-point checkout, show them the bad sensor, how you troubleshot it, how you found it, and then what you do to replace it or fix the error. But these point-to-point checkouts matter because it helps support this long-term maintainability and the troubleshooting as we have to go on, because you're more familiar with your system and the devices and just how things are working. So that's why a point-to-point checkout matters. Next up, we are going to talk about preparation, and we're going to start off with prep, talking about tools and documentation. So these are big things here. The first thing here is to always obtain, if you can, the most up-to-date control drawings and IO schedules that you have for your site or your project. These are going to be paramount for you to be able to get through the point-to-point checkouts because you have all this documentation already laid out in front of you. You have a reference to go back to if there's an issue or if you need to double-check something from manufacturer specs. Having all this documentation, the control drawings, and these IO schedules. The IO schedules are really important so you know where wires are supposed to land, where what points go to what when you get into the software. So again, we're talking about preparation here. So just remember that before we start the point-to-point checkout, make sure you have up-to-date control drawings and input-output schedules as well. Moving on, next thing is the manufacturer submittals and wiring diagrams. This is much like the first point here. We're just pretty much, this is prep work. We're gathering all the resources and materials that we're going to need to help us accomplish this point-to-point checkout efficiently and quickly. So we grab all this documentation, the diagrams, everything we need, have it all in front of us. That way it's available to us if we need it as we go through this. The next thing is a laptop with the correct BAS software and drivers. Obviously, you're not going to be able to command any outputs or read values back from an input device unless you have a laptop that has compatible BAS software and the proper drivers with it as well. So make sure that you have that. Check this off your list before you start your point-to-point checkout. You'll be good to go. Next thing, we're going to talk about some tools here. These are very common tools to have in the field for BAS techs. But digital multimeter, got to have a multimeter to check for resistance, voltage, DC, AC voltage, micro anything, milliamps, all this stuff. Gonna have to have a multimeter with its test probes, and then you got also have to make sure you have some form of communication cable to go from your laptop to your supervisory device or whatever controller you might be working with. So there's a few of the tools that you might need during this point-to-point checkout process. And then the last point on this slide, I know may not seem like a very big deal to a lot of you, but for me, this is huge, especially as you get into bigger buildings, bigger systems. Labeling things is huge because if you don't label something or you don't label anything at all, if you get through the job and everything works fine, but then let's think you go back 6 months down the road, you go back to the site and you don't have anything labeled. Something's wrong. You need to trace a wire out or you need to replace a bad sensor, but nothing's labeled. So it's going to be really, really, really hard for you to go back and find these things, fix them. And it's a hunting process. You have to hunt for things that you should already have labeled, and then you wouldn't have to look for them if they were. So big one here, labeling materials, have a label maker, pencil, marker, something, so that you can label wires, you can label controllers, you can label devices, label everything. Okay, don't take it lightly on the labeling portion. So make sure you have those labeling materials so that you can label all the pertinent things you need to label, and then the documentation templates. So if you can find some of these online, but you can typically find point-to-point checkout templates online, or you can create some on your own with an Excel spreadsheet or Microsoft Office suite. You can create all kinds of templates. AI is a really great tool nowadays that you can use to create these templates, but you can create a template for a point-to-point checkout. And basically what that does for you is it gives you a kind of a roadmap of how to go through your point-to-point checkout. So you can write down on there, you know, these are my input devices, these are my output devices. These are the programs that I've already set up, and then put check marks, but put check boxes beside of them. And then as you go through, check them off if they're good. Create a note section on one side of it so that you can put any notes. If there's a problem or you can't check it off if it's not good, then put some notes. Or if something was wrong and you had to fix it, put the note in there like, hey, this didn't work at first, but we went through troubleshot and found an issue with our wiring. We changed the wiring and now it's working. But these templates are a great way for you and your team to stay focused on task and together, teamwork wise, throughout the whole point-to-point checkout process. So make sure you have plenty of labeling materials and create these templates if you can. It just makes everything way easier on you and your team. And it's just way more streamlined in my opinion. All right, so that's the preparation work with tools and documentation. Next thing we're going to talk about is the pre-checkout review. So this is going to be before we do the checkout, we're going to review a few things. So we're going to start off by verifying that all the physical installation is complete, and that can be including, wiring, devices, controllers, making sure everything's already pre-installed, ready to go. And it could also mean checking your software version on your computer, making sure you have the most up-to-date version of your software. So that's checking, making sure everything is installed. The next thing is to confirm that you have power and network connectivity to the certain devices that need those. So, you know, for controllers and certain output devices, you're going to have power for those. So those are powered devices. You'll have to have power to those at all times. And then network connectivity. So for your controllers, if they're BACnet IP controllers, you're going to have a Cat6 cable running between them, either in a daisy chain pattern, or if it's MSTP, you might need a RS485 twisted shielded pair wire as well. But you have to make sure all this stuff is done. This is the pre-checkout review. So we're going through making sure all the installation is complete, and we're confirming that controllers have power, devices have power, and that our controllers and our software, everything is communicating as it's supposed to. So once we've checked that, next thing we can go on to is checking our input-output mapping in the controller. So we're going to get in our software. We're going to take that I/O schedule that we were talking about a little bit ago, and we're going to check and make sure that our inputs and outputs are mapped to the controller just like they're supposed to be per the schedule, okay? So that's what this is saying. Check the I/O mapping in the controller, use that schedule, double check your mapping, make sure everything's right. So once you've done that, then we can move on to identifying what points are physical and what points are software-based. So, you know, a physical point is going to be temperature sensor, something that you physically wire up with tools and a wire. A software-based point could be a software set point. It could be an alarm. So you have to go through when you're doing these pre-checkouts, make sure you're identifying these points and whether they're physical or software-based. Once we've done that, then the last step for our pre-checkout review here is to plan the testing order. And again, if you've already created these templates like we talked about in the previous slide, this will be a cinch for you. You have no issues at all. You'll already have this pretty well planned out with the template already laid out. So you basically just give the template to your team, say, here's what we're working on first, show them what they got to go through, send them on their way, start the checkout process. So this is the pre-checkout review. Again, this is before we even start the point-to-point checkouts. This is just verifying that we're to a point that we can do the point-to-point checkout. So now we get into the step-by-step. So now we've done the pre-checkout review. So checked everything looks good to go. Now we can begin our process. So to start here, we've got a step-by-step process. This is how I typically would have done my point-to-point checkouts in the field. This is just basic. This doesn't go over every single point and checking we'd be here for 3 days if I did that. So this is just one point, just simple little things. So to start off here, we're going to identify our point. Example for this thing here is going to be a space temperature sensor, so like a wall-mounted zone sensor. Next thing, we've got our point figured out. So the next thing we're going to do is verify our wiring from the sensor to the controller. We do this with a multimeter, and we can either disconnect the wire and then bounce the wire together to get an audible beep to tell us that there's continuity through the wire and that it is working, or we can go to our software and we can verify the wiring physically and then go to our software and make sure that we're communicating with our controller okay. So once we've done that, The next thing we can do is apply a test signal or manually actuate the device. So this is talking two things here. So we can apply a test signal. So this would be like a given resistance reading for this space temperature sensor. And then we can take a resistance temperature chart, and we can verify to make sure that we're getting the right resistance reading. And then the second point on this here is to manually actuate any device. This could be like a valve actuator or a damper actuator, something like that. So step 3 here is to apply our test signal so we can verify our wiring and stuff, everything's working good. And then step 4 here is to observe the value in the software. So we're going to our front end, our workstation, and we're going to pull up this point, and we're going to see if our value matches what we should be getting from our room. And you can also do this with a handheld thermometer. If you walk in the room, set it by the thermostat or by the sensor, you should get a pretty close reading to what the room's reading, and then you can go back to the computer, to your workstation, the software, and verify that you're getting close to the right reading. So that's step 4. We're observing the value in the software. Step 5 here is to confirm the correct engineering units and scaling. So this is just verifying your software configuration for this. So make sure that, if this is a space temperature sensor for us here in America, we're going to set that to degrees Fahrenheit, right? So we need to make sure that our software configuration reflects those as well. And then the final thing here is to document the result of this test. So we just tested one point, which is a space temperature sensor. And once we've done all this, if we got good proper readings, if our software has been configured correctly, we go to our documentation template that we already pre-created, and we'll document in there the result. Yes, it was good, no problems, or it was not good. Here's what we found. This is what we're going to do to fix it. That's typically how the step-by-step process works for this point-to-point checkout. So now that's the step-by-step. So now let's get a little bit more in detail when we go through and do these point-to-point checkouts. So the next slide here, we're going to talk about input verification. So this is going to be our analog and binary inputs. So to start here, when we're talking about checking our analog inputs, there's a couple things we need to check here. We need to verify that our voltage or resistance are within the expected ranges. So again, our analog inputs are going to be things like temperature sensors, humidity sensors, CO2 sensors, things like that. So we're going to check our voltage and resistance readings to make sure that they're within those expected ranges. On the other side of our inputs here, on binary inputs, this one we're just going to confirm the contacts are working as they should. So if it's normally open, normally closed, versus when it's energized, make sure that contact's responding how it's supposed to. And then true-false responses as well. Again, binary is just a two-state point, so it's just going to be either on or off, true or false. They're kind of interchangeable here. So that's when we're checking those, just making sure we're getting a status or something coming on and off. Should be good there. Third point here with input verification is sensor calibration verification. So if you remember in that last step-by-step example, our example for that was a space temperature sensor. And I said if you really wanted to be really detailed in checking that room sensor, you could take a handheld thermometer into that room, set it on the thermostat or close by the thermostat, and then wait for it to come down to whatever the room temperature is. Take that reading, and then go to the computer and see if your value at the software is close to that thermometer reading. Now, obviously, the thermometer and the actual sensor itself may not be calibrated to the same standard. So they could be different, but just know that if they are way off and you are getting a reading from your space temperature sensor, you may have to calibrate something or put an offset in the software in order to make up for that difference. But that's what this is saying when you're talking about sensor calibration verification. We're just verifying that the sensors are calibrated correctly and that they're reading how they should. Last point for the input verification here is to label any discrepancies and retest. So again, I was saying if we had a problem, we would label it as, something's wrong, or we just leave the checkbox open and then put a note beside of it and say, hey, here's what was wrong. We need to do a repair or fix this or calibrate this, and then we'll retest it. And then you could go back through, test it again. If everything works good, then you could cross that out and then just check it off so you're good to go. So this is just telling you to label any discrepancies and retest if needed. So this is input verification. So now that we've covered input verification, let's talk about output verification. Again, same deal here. We've got analog and binary outputs. So with analog outputs, we're going to check voltage or current signal from the controller. So we're checking the terminal screws on the controller to make sure that we're getting a voltage or a current sent out from the controller. If we do there, then we'll go to the device that we're controlling and we'll check it there as well. And the example here would be like an analog output 1 sending a 5-volt DC signal to like a hot water valve actuator. So we would check at the controller, make sure we're getting 5-volt DC out of that analog output 1. If we are, then we could go to the actuator and we could test it there with a meter as well to make sure that we're getting the 5 volts there as well. And if it's a valve actuator, if it's a 0 to 10 volt actuator, if it's a 5 volts, your valve should be about 50%. So that's analog outputs. Next thing we're going to talk about is binary inputs. Binary outputs. We've already talked about inputs. So binary outputs here coming up next. So this one is we need to check and make sure that our contacts are closing if we're sending the signal out. We can check this with a multimeter. We can check this with the continuity tone beeper on our meter as well. But we would check this contact closure with a multimeter at the controller. So example here would be binary output 1 at the controller with closes with a BAS override. So we override a fan start stop, for instance. We can check the contact on the controller, that output contact, make sure that it did close when we overrode it on. So once we've done those examples there, we can go down here to the third point. This is telling us to verify proper device operation. So if we look back up there at analog outputs, what I was saying with the 5-volt DC to a 0 to 10 volt valve actuator, if you sent 5 volts to a 0 to 10 volt actuator, it should be about 50% open. So we would send that 5 volts out, then you would go and look at the actual actuator to verify that it is actually at 50%. So that's what it means when it says verify that the device is operating correctly. That's what you would do. And then much like the inputs slide there, we're going to record the operation time and feedback if available. Again, remember guys, with these point-to-point checkouts, documentation is everything, okay? So we're recording everything that happens, everything we see, any problems, any good things, document all of it, okay? So those are our input and output verifications. So that's how we're verifying those. Next up, we're going to talk about some really common issues that you guys might see when doing these. So common issues with troubleshooting steps here. So if we have, for the instance, this first one here, say we have no signal response from like a temperature sensor. So to check this one, when we're talking about troubleshooting, we would do a wiring check. So we verify that the wire's not cut somewhere, or maybe we have a wire that didn't get terminated correctly and maybe it popped back out of the terminal screw. The next thing we can check is power. So make sure if it's a powered device that it does have the sufficient power that it should have. And then go to the device itself and check. It could be physically damaged. Somebody may have hit it with a hammer by accident or pulled it off. If they were climbing a ladder, maybe they grabbed onto a duct temperature sensor by accident as a handle and then just ripped it down. You never know. Crazy things happen in the field all the time. So if you're not getting a signal response from something, these are some common troubleshooting steps I would take to fix and verify and come up with a reason why I'm not getting that signal response. The next one here, we're talking about software. Troubleshooting steps for an incorrect value within our software. This one here could be a configuration issue. So I would probably start in the software and make sure that our scaling and our sensor ranges are set as they should be. Again, you're going to have to set these ranges when you go into the configuration for these. And if you get them wrong, they won't read right. So you got to go back, verify those, and if they're wrong, fix them. Third point here, talking about outputs. So we have an output that is not responding to commands. The first thing I would check is the override status in the computer, our software. So make sure if it's not responding, but we have it running from program logic. Well, if we have it overridden in the BAS, the program logic isn't going to be able to work it. So we have to make sure that the override is off, make sure it's not overridden on or off, and then check the control logic, okay? So if we've checked to make sure already, if we've done the point-to-point checkout on this specific output, and we have found that it does work with just overriding the point, and then we release everything and let the logic run the point itself, but it's not commanding anything, then I would say we probably have something in our logic that's keeping the output from being commanded on. So again, if your output's not responding here, just check the override status and check your logic on this. Probably the most common errors for those. The biggest one here, communication losses. Communication losses happen all the time in BASs, guys, so be prepared for this one. But two common things here to check when we're troubleshooting a communication loss is to check confirm the network setup, make sure that your network setup is correct, and then go through and check your communication wiring. Make sure that it is integral. Make sure everything is correct with your wiring. There's no nicks in anything. Make sure that your topologies are right as they should be. Go to your network map if you have a network map of your building architecture for your BAS. Run through that and make sure everything is laid out how it's supposed to be. So again, these are some common issues that you'll see, and just a couple simple little troubleshooting steps I would take for those issues. Next up, we're going to talk about documentation best practices. So again, if you guys haven't seen the theme here with today's episode, you've heard me say plenty of times, documentation is everything when we do these checkouts. And this is true not just for point-to-point checkouts, but it's also true for commissioning. It's also true for preventative maintenance. It's true for everything, guys. Documentation is huge. It will save you so much time, so much headache, and it just makes things run so much better. So take the time, do the documentation. I know it gets tedious, and I know it's probably on the back burner for a lot of you guys. It was for me as well when I was in the field, but it's, these are really, really big things. They will help you if you do take the time and do them. So a couple best practices when we're talking about documentation. The first one here is to use standardized checkout sheets. And this kind of goes back to what I was saying about those templates. So if you've created templates or you've gotten templates from somewhere, these could be standardized for, point-to-point checkouts, could be standardized for commissioning, could be standardized for preventative maintenance. You just have to find the right things that you need for the job that you're doing. So if it's a point-to-point checkout, like we're talking about here, make sure you're finding these standardized checkout sheets for a point-to-point checkout process. That way, everybody has the same material that they're working from. You can make copies of all these, so all your teammates have the same pieces of paper, same documents in front of them. Everything matches. Everything's organized. So make sure your team's using the same copies of everything, so nobody gets confused, nobody gets lost. The next best practice here is to record the test conditions and results. And again, we've hit this point till it's blue in the face in this episode today, but we're recording everything when we go through this point-to-point checkout, okay? We're recording the test conditions, so how the room is before we start the test, how it is after, and then we're also recording these test results as well. So whether it was a good result, bad test result, if it was a bad test result, what can we do to make it a good test result? What can we do to fix the problem? You have to record all this stuff, guys. It really, really helps. Third thing is to note any deviations or corrections that you make. So this is talking about the results and the test conditions as well. So if you take deviations from a test that you've already done, make sure you note that down. If you have to make corrections to a test that you've already done that was wrong, make those corrections noted, and then go back and fix the ones that you've already done too. And then the last point here for this one is to save digital copies for commissioning packages. So typically how this works, guys, is we get through the point-to-point checkout, and then we'll hand this point-to-point checkout in a package over to the commissioning agent. And then usually he has all kinds of stuff that he runs through in commissioning. But you'll save him a bunch of time, and you'll save yourself a bunch of headache and questions if you have this documentation and you're able to hand it off to him or her whenever they get to do the commissioning process. So again, guys, just big key here is to remember documentation is huge for these processes. Next up, we're going to talk about working with the commissioning team. Big thing is to communicate completed checkouts sooner rather than later. So again, we complete a checkout, make sure we're letting that commissioning team know so that everybody's in the know, everybody's on the same page. Next thing here is to log unresolved issues for follow-up and resolution so that they don't get forgotten. Because if they get forgotten, then the commissioning agent will find them, and then it's your responsibility to fix them so that he can carry on with commissioning. So make sure you're keeping track of all these and what resolutions need to happen for those. The next is to verify trend data and alarms after the checkout. So make sure that your trend data has proper trending in there. Also, make sure that your alarms are triggered when they're supposed to be. Go back and verify all those. And then the last point for this slide here is to support system functional testing phase. So we're supposed to support in the functional testing of our system because we've done the point-to-point checkout. We've verified that all this stuff works. So once we get into the functional testing, we can go back and look at this. If there's a problem, we can say, okay, well, it was working then. So what has happened? What has changed in between there? And then we can go back and look and see maybe if there was something in the software the commissioning agent changed. That could be why it's not working now. So again, documentation's huge for all this stuff, guys. Okay, that's what I keep trying to reiterate here. If you've got this documentation, it makes your job 10 times easier in the end. We're closing in on the end here, guys. So this next slide here, we're going to talk about mistake avoidance. So this is common errors and how you can avoid them. The big one here, very first one, skipping physical verification. Okay, if you can't physically verify that everything is set up and installed and operating how it's supposed to, then you're already missing the big first major step. Okay, make sure that you do the physical verification. The next one here, I've been guilty of this one in the past. Wish I never did because it caused me some heartache in the field as well. But assuming points work because they show a value in the software, or assuming because that point is just like other points, it'll work. Or just because this point was like the other point that worked, this one will too. That's a really, really bad way to be. And again, I admit I've done that in the past as well, just because time constraints, deadlines, that's still not an excuse. If you need to make the time to make sure that you're verifying all this stuff. Okay, don't make the excuses. Because it's the rework thing, guys. You know, you're assuming these things are working, but you have no clue. And if you don't know, it can come up and bite you and become an issue, and then you're causing rework, which extends the deadline out. That doesn't make anybody happy. So again, make sure that you're verifying all these, including same or like points. Okay, if you have 20 discharge air sensors in your building, doesn't matter. Check them all. Third point is failing to document the test results. I'm not going to beat up this one too bad. I think I've already hit this one pretty good, but documentation, guys, make sure you document. All right, fourth point is ignoring the scaling or unit mismatches. So if we have a temperature sensor, but we've got it set up for CO2, obviously it's not going to read right, and in our brain when we see it on the software, it's not going to make any sense. So make sure we're scaling our software configurations right, and make sure that our unit facets or their units of measurement match what the actual device is. And then lastly, not labeling devices, controller, and wiring. And I talked about this earlier in the slideshow, or earlier in the episode. Labeling just helps you troubleshoot, helps you find things. I'd always tell you, take the time to label everything. It'll help you out a lot. A couple pro tips here before we close out for today is to follow a consistent testing sequence. So find a sequence that works for you so you can remember things easily and just stick with it, okay? Don't deviate from it. Consistency is key here. Next thing is to label points immediately after testing. We're labeling this stuff right off the get. As soon as we test it, label it out. Make sure you know what it is, where it's landed, and so that somebody else that comes in behind you, they can see that label and also know that that's where it's supposed to be. The third thing is to use mobile devices like tablets for on-the-go documentation. So if you remember, we were talking about those I/O schedules and the control drawings earlier in the episode. This kind of ties in with that point too. So you can go ahead and download all this stuff on a tablet or your phone, and then as you're walking around your site, you don't have to carry around a book full of documentation. You just have one simple little device that you can refer to for pretty much anything you need on the site. Really, really, really good pro tip. I used a tablet when I was in the field, helped a bunch. So definitely recommend those. The next one, this one I cannot stress enough, guys. Communication is everything when you're in the field. If you don't communicate, then your teamwork's not going to be very, very great. So this is probably my favorite point on this whole slide for pro tips. Communicate issues when they happen in real time, okay? So if you see an issue, make sure you're communicating that with your team or the building or building operator so that everybody knows. And then also communicate when you resolve the issue, or if you resolve the issue, what you do to get to the resolution. You know, communicate all of these things so that everybody's in the loop, and it kind of helps them too, because if they're not familiar with what you fixed, you know, they may remember that in the back of their head, like, okay, well, that's what he fixed the last time he went there, so let me go back and look. Maybe it might be the same issue again. Another pro tip here when we're doing point-to-point checkouts is to review daily progress with your team, okay? This just makes everybody in the know, everybody's on the same page, and team cohesion is just at an all-time high when we have really good communication and we have daily meetings so that we can figure out where everybody's at, what people need, if people need assistance, people need support. These meetings are a great way to find those things out. So I'll always tell you guys, always have these meetings, always communicate all of this stuff, okay? So with that, guys, that is our episode for point-to-point checkouts. So for summary, in today's lesson, we learned that point-to-point checkout ensures BAS reliability and performance. We learned that preparation and documentation are the keys to success here. We learned to verify every point. Don't just assume they work, even if they are like points. Okay. Remember, I was saying about 20 discharge air sensors in a building. Test them all anyway. Fourth one here is to troubleshoot methodically and communicate effectively. Okay. So we have to be smart about how we troubleshoot, and we need to make sure we're communicating all this stuff as well. And then lastly here, a thorough checkout sets the stage for a smooth commissioning, and your commissioning team will thank you all over if you do your job right with the point-to-point checkout. So that is our episode for today, guys. Thank you for listening to the Smart Buildings Academy podcast. We hope you learned from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcasts or Spotify. If you're watching this on YouTube, please like, comment, or subscribe. As always, this will be available on our website at podcast.smartbuildingsacademy.com/519. Again, that's podcast.smartbuildingsacademy.com/519. This has been Ethan. I appreciate your time. Hope you have a great day.